Hi everyone, welcome to today's presentation, Bright Talk. Today's presentation is Controlled Test Automation Costs with Virtual Test Data. My name is Grigory Trofimov. I'm a Senior Solution Architect here at Parasoft. Let's talk about test data. Let's actually dive right into it. As you're joining, please feel free to add any questions to the question box. We'll address them as we go or address them at the end of the session today. Um, but to get started, let's just kind of go over the agenda for today's presentation. Number one, we're talking about test data, right? So where does test data come from? What is test data? Uh, there is an inherent cost associated with with test data in general, but we'll see how bad test data can actually exacerbate those costs. How does data virtualization work? So the solution we're going to propose here today for the overrun in terms of project, in terms of bad test data, is going to be data virtualization. We'll talk about how that works. We'll do a practical demo of this capability. And when and where should I use virtual test data? This is important because we're going to we're going to see where it makes sense, right? Where it makes sense, where more traditional approaches do make sense, where data virtualization, data simulation, these concepts really come into play. So with that, let's talk about test data. So what is test data? Uh, Canonically, test data is defined as data created or selected to satisfy the execution preconditions and input content required to execute one or more test cases. That's a pretty dry definition, right? So let's maybe think about it in easier terms. If you think about a lock, the way a lock works is there's these little teeth that have these different positions in the in the mechanism. And so when a key slides in, it actually adjusts those positions. It adjusts those little teeth to the right position, and the right combination of those positions will actually unlock your your lock, your locking mechanism. Test data is similar in that sense. So test data, if we simplify the previous definition, is it's data that you use for testing. But if you think about it in more complex terms, when we have a test case, we are looking for the right combination. We're looking for the right combination of preconditions. We're looking for the right combination of uh, inputs in order to satisfy a certain test requirement. And this can be a challenge, right? So just like trying to crack a lock, if you're picking a lock, there's actually a lot of very interesting information about picking locks out there on the internet. But if you're picking a lock, you're going to go through a number of combinations until you find the right one, and that could be a lot of combinations. For test data, that can actually be a much larger subset, right? You don't have just five teeth. You might have tens of tens of thousands of user permutations just for one type of account, and then you have another type of account, and then you have another type of user, and then you have another system that handles another uh, combination of preconditions. So facilitating test data for that is obviously a challenge. You need all the combinations, you need all the keys. uh, then there's the additional layer of uh, privacy, right? And in the identification of test data, we all know that there is very stringent policies. There's very stringent requirements as far as what is allowed in terms of test data. We're going to talk about that as well. But in a nutshell, again, test data is data that you need for testing, and a lot of times that data needs to be in it needs to be in a variety of flavors, variety of combinations in order to unlock all the potential test cases to validate your application. In general, when we think about test data, the preparation of test data for testing is a very time consuming phase in software testing. various kinds of research shows that anywhere from 30 to 60% of testers' time is spent on searching, maintaining, and generating data for testing and development. There's a number of reasons for this. There's, again, a number of statistics and research done that demonstrate different attributes and different sort of pitfalls and costs associated with test data. In general, it's probably one of the biggest challenges when it comes down to testing. We talk about agile, we talk about continuous testing, we talk about continuous delivery, but test data is certainly right there at the forefront. And without test data, you really can't do any of those other things, right? Agile, continuous testing, DevOps. You need test data. And test data is a challenge because number one, testing teams do not have access to data sources, right? Just having test data like that on demand, it's not something test teams have access to, right? A lot of times that test data is frankly production data, right? Some sort of subset of production data. And there's a delay in getting production data and giving that production data to testers or giving access to that production data to testers by developers. A lot of times it's very large volumes of data, right? So, when we talk about production data, it's likely a lot of data, right? Especially for enterprise applications, you're looking at enormous sizes when it comes down to volumes of data. We're going to talk about data dependencies and combinations and the challenges that presents, and of course, long refresh times, right? So if you're once you do have data and you've used up that data, if you've used up that data over the course of your test cycle, you need new data, and you kind of have to go back and you have to start all over again. So what actually makes good test data, right? So number one is good test data is realistic. Unrealistic data is can absolutely hamper the confidence of your tests, right? And confidence is probably one of the most important things in testing and software development. Confidence from a perspective of a developer, knowing that they're not going to introduce bugs into production. Confidence from the perspective of test teams, knowing that they are validating edge cases, that they have good test coverage, etc. And so when you don't have that confidence, you don't have good test practices. And unrealistic data can absolutely destroy that confidence. The way this contributes to just overall costs of your project is, when you see signs that that your defects are spiking, but you don't really know where that's coming from, you can't actually pinpoint the faulty process. There's a good chance that somewhere in your tests, you're using unrealistic test data that could be manifested in strange edge cases or one-offs that don't necessarily really make sense. Uh, it forces developers to go back to double check, triple check their results, and again, in general, it's just not a good practice. So your data has to reflect the reality of your application, the reality of the usage of your of your customers, and in your application as a whole. Data needs to be controlled within the team. So if teams don't have control of their test data, it can frustrate everybody, right? This can frustrate the developers. This can frustrate the test teams. There has to be a level of ownership. If the data resets at some time interval, well, this will ruin any customization that you already have set up, any preconditions, any state that you may have worked so hard to get your application into. You're not going to be able to verify the success of your test case. Developers and testers often have to spend time working around the test bed in order to make sure that the data is in the right state. And when you don't have ownership, when you have to wait for that test data to come to you, somebody else controls it, you're not able to do that. This obviously also contributes to project overruns. And there's an easy way to see that as well. So if you look at block cards, as far as large block cards, blocked work items that have long cycles, that's that's typically contributed to the fact that test teams don't have access to test data and they don't have any ownership there. If your developers are saying, "Hey, we need another test environment," guess what? That's probably another symptom of the fact that you don't have control of your test data. Visible state changes. So this is another big one. So what happens is, our applications, we're kind of used to thinking about our tests in terms of inputs and outputs, right? So if your test data is really hard to understand because it only focuses on the inputs and the outputs, and under the hood there's a long running process or a complex orchestrated system of asynchronous calls, backend systems, various other external dependencies, right? There's additional steps that are actually happening there. And when we only look at the input and output, we might see, get customer by ID and then get a response, with some account. But under the hood, we're connecting to some identity verification component. Then we're connecting to some account information component. Then we're looking at potential transactions that need to be processed before we actually return all this data. And so these state changes, when they are abstracted out, this means that we can't verify those steps, right? So the big thing here is that you're not able to you're not able to again pinpoint specific defects. Frankly, when you're looking at demoing applications, when you're demoing something and developers are having a hard time demoing something and it's not necessarily working the way it's expected, there's a good chance this is due to the fact that the data is not respecting the state changes that are happening behind the scenes. Finally, data needs to be decoupled. Data coupling is best defined as really just the degree by which a software component influences the execution of another software component. This actually goes hand in hand with state changes, but more at a service to service layer, right? So heavily coupled data ripples defects to all sorts of corners of your overall system. And it makes it really hard to figure out where the solution to a particular problem should be. Additionally, if you are making some changes with them, you want to be able to make those changes in one place and not have to, again, honor that rippling effect throughout the rest of your application, right? So good data should be decoupled. Bad data that is not decoupled is going to contribute to the costs of your project. So what are the traditional approaches to TDM? How do we get test data? Where do we get test data from? Number one, clone copy the production database, right? Uh, this is this is what a lot of organizations do today. This is probably what you're doing today. It's a great way to get data, just that you already have, right? You have production data. Let's just go ahead and reuse it. We're going to talk about the challenges associated with that, but of course, as an approach, as as a strategy in terms of obtaining test data, that's a big one. Subsetting, sampling the production database, right? So this is actually a natural consequence of the first approach. When you inherit all that data, you have to have some set of policies and some set of processes in order to uh, make sure that you have, well, safe data, and also relevant data, right? Or specifically data relevant for the test cases. Think about that lock again, right? We don't want to just try 60,000 keys and see which one will work with our particular test case. We want the right set of keys in order to unlock that combination. Third approach is to generate and synthesize data. This is, again, another common approach. We'll talk about the benefits and the challenges there. But the good thing about this is obviously that it's not real data, right? So when we talk about those policies, when we talk about all the things that you have to do with production data in order to be able to use it as test data, here you have a sort of a different approach where your data is made up, right? So you don't have to worry about uh, personal information, identification, and things like that. So the challenges with each one, right? So we talked about cloning your production database. It's expensive and it's time consuming, right? You're likely looking at a heavyweight TDM solution to do this. You have to implement rigid policies in order to ensure that the data is safe, that there is that it's compliant, that you're not breaking very strict mandates, various governments, whether the U.S., whether the EU, whether somewhere else. And typically that means that there's only a few people who actually have access to production data. So, when we talked about not being able to own your data, not having uh, data availability when it's time to test, when you're cloning and you're copying the production database, that's going to lead to those challenges. That's going to lead to those costs. Subsetting and sampling production data, it's this contributes to our later point about good test data, where we think about state changes and we think about decoupling, right? So being able to subset the right data, but also subsetting the data in the right places where other components within your system, where other components or application are honored with that subset, you have to have very intimate understanding and very uh, expert knowledge, not only of the data sets but also the system under test, right? And what those individual components are, not just the components that you're testing, but the overall system, the overall architecture, in order to make sure that you're subsetting and you're sampling the right data from that production database. If you're generating and you're synthesizing data, well, the challenge here is defining the logic, defining a model that fits within the use case, right? We don't just want to generate a bunch of random numbers. We don't want to generate a bunch of random accounts, usernames, etc. We want relevant test data that's actually going to help us validate uh, our application, right? We need to satisfy preconditions. We need to be able to verify the results. In today's world of modern software architecture, we know applications integrate to data sources via APIs, right? So, in many cases, these data sources are shared across multiple applications, and these APIs are also shared across multiple teams, right? So, the common issue here is if multiple teams are consuming data from the same database or from the same data set, you're going to have teams that are consuming each other's data. You're going to have teams that are burning each other's data. It's going to lead to a sort of a knock on effect where you can't necessarily validate your results uh, just because, frankly, there's other teams doing their work at the same time. So, to kind of summarize everything, right? Shared test environments, TDM solutions that are heavyweight, uh, teams not respecting data integrity, those are all contributing factors to cost in terms of project overrun, just based on acquiring the right test data. This can result in defects, obviously. If you don't have the right test data to validate your test cases, you're bound to have defects. So when we think about overall costs, we have development time waste, we have test time waste, we have design time waste, and then we have defect related waste, and these are all individually contributed to test data. So what's our solution here? Simulated test data, virtualized test data. The idea here is that we are going to extend service virtualization capabilities. If you've looked at service virtualization before, you're very much aware of the fact that we can simulate APIs, we can simulate services, we can simulate just about any component within your system. But that doesn't have to stop at a simple mock or a simple stub that's going to return a 200 ping or a 400 error condition from that particular service. We can actually extend that. We can take our virtualized services and we can data drive them in a way that satisfies our test cases and in a way that actually is a cost effective way to obtain and share test data with test teams and give them an opportunity to actually own that data, give them an opportunity to own their own test environments for validation. To reiterate, right, service virtualization takes place of your APIs. Each team can deploy their own virtual service. Those virtual services are managed by either a test environment interface or a test data management interface. Um, the fact that each team has their own test environment means that they own that data. They own that data. They own the conditions. They own their test cases. They own their regression test suites. Therefore, they can go back and they can create the data or synthesize the data or subset the data or mask their data in a way that satisfies their testing preconditions. So with service virtualization, the key pros here are number one, doesn't require an underlying a database infrastructure. You may still see teams actually use a database for housing their test data, right? The key thing here is it does not require an underlying database infrastructure. You can maintain your test data in various other types of external sources. Those could be CSV files. Those can be some data repository or some other form of a table or a file. But having DBA experience, having intrinsic understanding of your database is not a requirement here. And frankly, if you are using an underlying database for your test data, that could be just about anything. You can, you can format that, you can slice and dice that however you want. Isolated test environments, we're going to talk about that in a little bit more detail, but this goes back to that ownership component, right? You own that test data. You can isolate your test environments with your test data. Easily cover corner cases. So being able to manipulate the data either on the fly or without worrying about other teams to kind of get those edge cases. A big win there for our test teams. Easy to share, right? So being able to duplicate, it's not the same as that one person who has access to production database who has to clone the production database, uh, de-identify the production database, and then share that data with everyone else. This is something you can take and distribute to anyone else who may need access to that test data. Eliminates the complexity of underlying database schema. So this is something we had covered already. And then capture just the data you need to and dynamically mask. Now this is, you know, this is important because as a testing organization, most of the time we already have our test regression suites defined, right? We know what use cases we need to facilitate. So if we have some some of this already defined and we're using a common approach in service virtualization, which is to record data and capture that data, guess what, we're going to capture exactly the data that we need. We're not going to end up with an overload of data. We're going to capture exactly the data that we need to run our test regression suites. Now this isn't an absolute solution, right? There are sort of caveats here from a perspective of test data management. Number one, it's not a real database. So if you want to virtualize SQL logic or queries that do things like inserts or updates, you can absolutely do that. That's not a functional limitation of this approach, but it does add a certain level of complexity. And so, with that, let's actually dive into the demo portion of today's presentation. And if you've seen our presentations in the past, you've probably seen our trusty demo application called Parabank. And within Parabank, if you haven't seen Parabank, it's a simple banking application. As a user, I can log in, I can view accounts and things like that. And before I actually do anything, before I execute, well, yeah, let's just say execute, a basic test against my application. Um, I want to make sure I can do this over and over again. I want to make sure I actually capture some data for myself to reuse in future test scenarios. And from that perspective, this is where service virtualization comes in, right? So I have a virtualized server that's deployed in the cloud, and I have a JDBC proxy essentially that allows me to access a number of different modes. Currently, we're in a pass-through mode, which means my application is passing through the proxy directly to the database, and the database returning data, passing that data back to the application. These other options have record capabilities, virtualize capabilities, hybrid, and failover. So let's start with the record. We can see our little red dot right here. And what this means is when I do interact with my application, we're just going to do something basic here. We're going to log in, and this is going to return a list of accounts and account balance and available amounts for those accounts. And perhaps this is the data that I want to start with. This is the data that I actually want virtualized, and this is the data that I want to reuse. Well, from a service virtualization perspective, what we do is we create virtual assets. We create virtual services, right? And that's what we're going to do. We're going to create a virtual service. We'll call this uh, virtual data. How about that? Oh, looks like we already have one. Let's do virtual test data. And we're going to use recorded database queries. So this is coming directly from our JDBC proxy. We're going to connect to our server that's hosting the proxy. We're going to use a data repository to store our data. A data repository is basically our way of structuring data and making sense of complex hierarchical data sets. We do have a server that we can use to host that data. And at this point, we're just going to go ahead and hit finish. And while it's doing this, so it's going to download some database recordings. It's going to import these recordings into our data repository. What we're looking for in our data repository really is the list of these accounts, right? We want these accounts with these account numbers, with the balances, with the available amounts. And so as soon as our um, our download finishes here, there it is. We can actually take a look at that data set. And I have my data repository here, and we have a new data repository data set, which is a SQL data set. And if we take a look at it here, this is what we see, right? We see a list of SQL queries, right? We call them SQL templates because they're templates because they are parameterized to various values. This means that if we're passing in other customer IDs or passing in different names, we can actually still correlate the right data sets with the right values. And if we drill into the actual data set, so for example, this one here where we're getting, this looks like actually where we're getting account information, type balance, right, from account where customer ID is customer ID. We have a result set, and this result set is going to return a list of customer IDs, types, and balances. Now, if I actually uh, go back to my proxy here and I say, you know what, let's actually reuse this data. Let's use this virtual data, and let's validate that we can do that. Let's go ahead and refresh our page here. Oh, let's go ahead and log in again. Do one more login here. No, actually, let's actually change perspective. Let's use another instance of our database here, and let's use a virtual data set. Let's go ahead and provision this. And so this is actually a slightly different data set. This is one that we've already had pre-recorded and pre-configured. And if we take a look at this, it's essentially the same data, right? It's our list of accounts. And if we drill into this, it's the same query, right? It's the same API call where we get ID, customer ID, type, balance, etc. from the account. And here we actually have four accounts that we can use with our application. And so if we go back to Parabank here, oh, come on. Okay. Mm, no problem. We have a backup. Let's go ahead and use another instance of my application. Here we go. And let's actually also make sure that that environment is in the right state. We'll talk about environment manipulation here in a second and what we can do with this. In short, this allows me to deploy various environment instances of my application on the fly, right? I can actually do these changes fairly quickly and get my application into the right state because I have test data ownership here. Okay, and if we actually go ahead and log in here, there we go, right? Here's my list of my four accounts with my virtual test data. And we know that this is virtual test data because at this point we can actually make changes to the test data. Let's um, let's actually let's actually do this. Let's validate our application and see how our application responds when we have a negative balance with a bunch of zeros. Let's see if we have serialization logic here in order to take care of that. So I just went ahead and made that change. If I go ahead and update my application here, oh, let's see. Do I need to? Do we make the change here? Yep, there's change, and then let's go ahead and refresh that for ID. Oh, let's do this one. And now let's go ahead and refresh our application. Oh, it looks like it's not taking that change right this second. So we'll take a look at why that is. But in any case, the idea here is that when we do have ownership of our test data, we are able to make these changes. We're able to make these changes on the fly. Um, now, this gives us a couple of things. This flow is basically, this is your common service virtualization flow. You're defining proxies. You're recording traffic. Uh, on the fly, right? You're executing your test cases, you're capturing that traffic, and based on that traffic, we're able to create virtual services and virtual assets that that we can use to redeploy with our application under test. The same proxies, the same controllers can then be reused to direct the flow of the traffic, right? Whether we're pointing directly at a live database or another external service, where we have some sort of failover flow where we first try the real endpoint, then we fail over to the fake endpoint or virtual endpoint with our virtual test data. All these flows can be controlled within your CI/CD via Jenkins, via Azure DevOps, GitHub Actions, etc., and can be easily automated with REST APIs. This gives you a number of things. First of all, this gives you realistic data up front, right? So we talked about having unrealistic data. This is realistic data because this is data that's coming from the database. Number two, it actually gives you control of your test data, right? So again, being able to manipulate data on the fly, being able to make changes right there, and then this is a key component to reducing the cost of test data availability and test data maintenance. So let's talk about state changes and data decoupling, right? Let's say we want to make some changes within the application. Well, uh, we saw here I was able to sort of manipulate the environment. I was able to deploy a virtual instance of my application, a virtual instance of my um, of my accounts, right? And this is part of our environment-based approach to testing, right? Rather than singling out a specific service or a specific stub or a specific component, we are actually able to configure a complete environment or a complete set of components to either a virtual, a live, or a real state. This gives us a lot of control and granularity in terms of what our tests actually doing and the preconditions that we need to satisfy for those tests. A good example of this, and we'll cover this shortly, is airline systems, right? So airline systems that connect to ticketing systems, cargo systems, passenger availability systems, and things like that, right? When you deploy an environment, you really need all of those components in a certain state and a certain sync in order to in order to facilitate a full uh, regression test. This is an environment-based approach to testing. So with that, let's actually look at test data generation. So once we actually acquired that test data, once we've actually created a test data set, how can we grow that test data in order to facilitate our test requirements? A good example of this is performance testing, right? If you're doing performance testing with your with an application that requires a unique user for every type of test, well, for a performance test, you're going to end up needing close to 30,000 or something like that different usernames and passwords. This is a real use case from one of our customers. What they're able to do is they're able to generate new users and new credentials on the fly using test data generation capabilities with their virtualized test data. So let's switch perspectives here again, and we're actually going to go back to Parasoft CTP. So this is our test data module here, and if we take a look at our model, at our uh, uh, database model, this is really interesting because what we see is that our our test data is not flat, right? We have objects, we have elements, we have things nested within those objects that um, that really define the model of our service and the model of our application. And somewhere in here, we will find things like balances and customer IDs and account types. Maybe for some account specific data, we'll find something like an address or a username, password. There we go. Right. So this is all account related information here that has its own structure. It has its own geometry. But for our use case, what we might want to do is we might want to, let's say, instead of having four accounts within our Parabank application, we might actually want to um, create a bunch of accounts, right? We might want to. Oh, and actually, yeah, that's we're in the wrong one here. Okay, so we might actually want to create a scenario where we have 40 or 40 something accounts, right? So first of all, let's find our accounts. Let's find the elements that have balance. Okay, and what we can do here is we can actually infer constraints. And what inferring constraints will do is actually it will take a look at all the data that is already in the system. And based on that data, it's going to tell us, hey, these are the maximums, these are the minimums, this is what type of data it is. And when we say, okay, well, let's actually generate new data or let's mask existing data, we can actually set these constraints. And perhaps negative, let's actually do somewhere from a negative $1,000 to anywhere to uh, $30,000 as far as accounts. And we're going to generate random amounts here. For our customer IDs, we are going to set mask and generate settings, and instead of random, um, we'll do ranged, right? And we're going to increment by one, and going to have a minimum account value of, this is actually our customer ID. We want a we want account IDs. So we'll do arranged, and we'll start with a minimum of 1300 all the way up to somewhere in the 500s. I think at this point we're actually good. So this is sufficient for us in order to generate a new test data set. And we're going to go ahead and just say, let's generate new data. Uh, We can do this again. We can do this on the fly. We can do this with the curl command and go ahead and click generate, and that creates a brand new generated test data set. Now, I actually want to reuse this test data set. And in order to do that, I'm going to go ahead and go to my service virtualization module. I'm going to find my virtual asset that's responsible for delivering this data. And I'm going to go ahead and update the data source. This goes back to decoupling, right? If I make changes to my data set and I want to implement those changes without having to redeploy my application under test, that is going to save me a ton of time. That's going to save me a lot of running around and figuring out who else is using this test environment. And if I go ahead and refresh this, well, um, looks like we are still not getting the results we expected here. So tune in for one of our, oh, we actually are. We are getting results. We are getting our incremented accounts. The only thing we did not do is we did not actually set it to generate 40 accounts. So if we go back here and we just take a look at our data set, our data model one more time, and we look at our constraints here. So let's look at balance again. There it is. And this is actually the test data set that is responsible for generating the number of accounts. We can modify this. Let's say instead of 4 accounts, we want 44 accounts. Okay, we're going to save that, and we're going to go ahead and generate one more time. Let's call this generated 2. And now, if we go back to our service virtualization model, let's just update it one more time, make one more change. All right. Now let's go ahead and update our page here. There it is. Okay, so there's our accounts. There's our balances, right? We've got some negative accounts. We've got some positive accounts, anywhere from negative 1,000 to 30,000. This is exactly what we're looking for, and now we're able to do some sort of validations and ensure that our application can actually handle this. So let's actually review. We're able to generate realistic data by capturing data and recording that data. We're able to control our own data because, well, our test environments are isolated. We can make state changes in real time, right? We can track those state changes because uh, that data is identified by the services that we're virtualizing, and our data is decoupled, which means we can make changes to one data set without affecting other data sets. We can make changes to our data without actually affecting the virtual components within our system as well. This all rolls up to CI/CD, right? When you're able to do these things, when you're able to isolate your test data from extensive complex flows in order to acquire that test data, this enables you to do things like deploy and destroy ephemeral containers, ephemeral test data. Um, all rolls into your DevOps workflows and continuous testing flows, and extends your test coverage, right? This is actually going to enable you to cover those additional edge cases, conditions, so on and so forth. When we talk about decoupling, it makes your test environments a lot more portable as well. So the key thing to remember here is now that you have access and you have control of your test data, you have a lot of flexibility in terms of giving access to other teams and partners as well. So if you have external applications that need to integrate with your systems, or you have various test teams that require a special type of data or a special type of access, and you have a predefined template for what those virtual services and that test data looks like, you can not only service all those teams, but you can actually also isolate all those teams in their own environments. All they need is their own server and their own test data set. This all plays very nicely again with containerization, Kubernetes, etc. Being able to stand up these environments and stand up these components on demand. So when is the right time to use this? When you have agile practices, right? So agile teams will demand a faster paced uh, uh, test test and development environment, right? So being able to simplify the TDM problem, right? Reduce the dependency on those production databases, and also being able to link your virtual services with your test teams in order to give the test teams actual control and give test teams access to that test data. This is going to reduce the project overrun. It's going to enable test teams to do testing within the same sprint. It's going to reduce their dependency on DBAs and the specific state of a test environment in order to do their testing. This is all very well documented. We've actually have a QA financial report uh, that outlines this in detail with metrics and um, calculations in terms of how much time this is saving, how many defects this is preventing from escaping into production, the general uh, time savings on each project. Please feel free to scan the QR code and you'll have access to the QA financial report there. Real customers who do this, these are, again, these are real customers, these are real use cases. Um, uh, Brian Papineau at Alaska Airlines did a fantastic presentation, actually a couple of times now, detailing how they are able to use service virtualization to solve their test data challenges. Please feel free to check it out. And to summarize, again, these are simple tools, right? This isn't something that you need years of database management experience with, right? These are testing solutions that are easy to use, that are point and click. They are low code, so you do have access to scripting capabilities when you need. There's a lot of capabilities there in terms of being able to automate flows with REST APIs, being able to define test environments, being able to do CRUD operations, create, read, update, deletes with your test data, and it is highly scalable, right? So these these technologies are proven, they're validated for, you know, thousands of concurrent hits per second, and with modern implementations of infrastructure hosting and DevOps, this is something that can be scaled out within seconds, both vertically and horizontally. To learn more, again, please scan the QR codes, check out parasoft.com. Um, we have a ton of resources there and information about the ability to implement test data management solutions using service virtualization and reducing costs. With that, I know we're a little bit over time here, but I do want to take a look at some questions, and let's see if we got any questions here. Okay, so first question is, does this only work for REST services? No, absolutely not. So, with service virtualization, you are able to virtualize. So at this point, it really comes down to the solution that you're using, right? With Parasoft, we support like 100 different protocols, different message formats, message types, etc. We You can check out all the everything that we support in our marketplace extension, but you can do this with queue-based systems, with event-driven architectures. You can do this with TCP uh, protocols, custom TCP protocols, right? You can data drive just about any virtual service because that test data is decoupled from the virtual service itself. Great question. Do you have any integrations with Jenkins or Azure DevOps? Yeah, absolutely. So if you if you check out our documentation, we actually have plugins, we have actions and things like that that we've developed for Jenkins. For Jenkins, it's a UI plugin that you can leverage for instantiating environments within your system. And for Azure DevOps, for Bamboo, for GitHub Actions, right? We have additional integrations that you can use to within a line of code, or just by modifying your YAML file, you can implement service virtualization capabilities to stand virtual environments up on demand. What types of databases do you support? We actually support a pretty broad spectrum of databases. The way we communicate with databases is through a JDBC driver. So typically, if we can connect to your database with a JDBC driver, you're pretty much good to go there. Uh, there's there's probably some edge cases there, but at the end of the day, please please do reach out if you have a specific use case and you're not sure whether or not your database is supported. Please do reach out to Parasoft, and we'd be more than happy to take a look at your use case. So with that, thanks again for joining today. Again, please check out parasoft.com for more information, and we'll see you next time.